Okay, even though we typically do electrical engineering tutorials, we have been doing the wiring in our house and we've been learning a lot of different stuff, and I want to share some of the things that we've learned just so if somebody asks you, you can have a rough working knowledge and don't embarrass yourself too much. So this is a CircuitBread practical tutorial. I just want to emphasize though that even though we're going to learn some of the basics here in the US, it is way more expensive to get a ride in an ambulance than it is to hire an electrician. So first of all, if you aren't comfortable with it, don't do it. Get an electrician. Second of all, never work on a live panel. This panel, one, it's not completely made up, and two, it's completely disconnected. So nothing here is live, and that is why I'm going to be comfortable with it. So with that, let's get into talking about this main service panel. So here, it kind of might be overwhelming with all the things coming in, but let's start at the top. Right here we have 4 wires coming in, and these are basically our service wires, and we have the ground wire, which isn't hooked up. We have our 2 power wires, and we have our white neutral wire. And you'll note that the coloring is actually used other places. So power is indicated by black and neutral is indicated by white. And then in some of the 240 applications, you'll have both the red and the black to match these 2 hot lines. So these lines come in and they energize these 2 hot lines. They energize right here. These are protected so that if it were hot, you wouldn't accidentally zap yourself. They come down and make these 2 bars hot. And these bars are what these breakers attach to. So with that, let's actually go down and we can look at some of these breakers. A bit tough to pull out. So I've got this 20 amp breaker, and you'll notice there are different types of breakers. We've got our AFCI, GFCI type breakers. We have some tandem breakers, and we have our single breakers, and it shows the amperage that is rated for each of them. So most of these are 20, and then you get a couple of 15s. But as I pull that down, hopefully you can see, you have this bar right here that has something coming up that your breaker attaches to. And then over on this side, it's actually attached to the bar that runs on the other side. So if we were to look up at the top, this bar would be connected to the black, and this bar would be connected to the red. And then as these are going down, each one alternates between which bar it is attaching to. Now, these are all our 120 circuits right here. And so they're only connected to one bar, and they only have one output. However, on this side, we have quite a few 240 volt applications where they are double pole. So like in this case, you can see it is actually connected to both the left and the right. And that is because these 2 both are 120 volts, but they're out of phase, so that when the 120 of one is high, the other one is 120 low to give 240 basically peak to peak right there. Of course, that's RMS, so it's not technically peak to peak, but you get the general idea. And the way you get that coming back down here to the breakers is you get one that is attached to the black and one that is attached to the red. Now, honestly, it doesn't really matter. I don't know which one's attached to which, but it is indicating that these are 2 different connections and not just connecting to one or to the other. So with that, let's go into the other things. That's the power bars, but then you have this neutral. But it comes down here and it shoots out the sides, and you can see it's connected to this neutral bar. Now, for most of your standard circuits, you can just connect your neutral bar in there and everything's fine. Everything works out just fine. But with these new fancy AFCI, GFCI ones that are required by code for a huge amount of locations, you actually need to tie the power and the neutral together. So you can see the power's up there and the neutral's right there. Whereas such as with this one, you just have to hook up power and the neutral's hooked somewhere on this bar, which makes it quite a bit easier. It's a lot smaller, and it's also about 10% the cost of these things. These things are crazy expensive. So we've talked about the neutral, and that comes in here, but now we have the ground. As an electrical engineer, it really confused me because I had neutral and ground, and I didn't quite understand, like, okay, how should I treat these? Basically, if you're doing circuits, you can think of neutral as ground. This is where power goes from here to there, and don't even have to worry about it. Even though electricians will call this neutral, and that's the technical correct name, you can think of it as ground. Now this, what is called ground, is actually just a safety feature. And so this is attached so that if there's any stray electricity that, like, let's say one of these comes loose and touches this box, instead of energizing the box so when I touch it and I get fried, it will go through this ground, which goes to the literal ground outside, where there's a couple of copper rods driven deeply into the literal ground. And so this needs to be hooked up, and all of these circuits actually have on the outside here connections to the box itself. So basically the entire house is grounded to this box, which will ground through this. So if there are any safety issues, any stray electricity will go through the ground and go to the ground instead of killing us as the human beings that are operating around it. Okay, so I think that's it. Again, this is where the power comes in. It's distributed through the hot 120 here, 120 here, the neutral right here, unless it's directly tied into here, and then the ground on the outsides. The breakers are all set up in different ways with different amperages, and if you get the dual poles, that's so you can get the full 240 volts to your different things. Like this is our heat pump, so it needs 240 volts and it's 40 amps, so it's a rather large load. But that's basically all you need to worry about here. In terms of safety, this will always be covered, and so as long as you have that on, there's really nothing you can touch to hurt yourself. And even once you pull it off, the only thing that should hurt you is the black. So like touching these things or getting your fingers in and touching those and stuff like that. But even though that's the case, I mean, I wouldn't touch anything, and I wouldn't even have this open like this if I didn't have that breaker, the big breaker that shut off the power to all of this. Because again, safety first. There's no reason to kill yourself for any of this. But I hope that is helpful with this overview of the master service panel, or the circuit breaker box. If you did enjoy it, please like this video, subscribe to our channel to learn more about electrical engineering tutorials and things like that. But we'll actually do a couple more practical things for the electrical engineer. And that is it, and we will see you in the next one. Take care.